Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the Earth to, actually I guess it's a Moon to Earth to Mars video series that I'm doing. And this is not a mission, we're not going to do a full mission. This is just to explain how to start off on the Moon, drop down to Earth to get that gravity sling, and then go off to another planet. I've already done another video on this topic, actually two. But hopefully you've at least seen the last one where we started off on the Moon, dropped down to Earth, and went off to Venus. I'm going to do another video just like that one where I'm explaining how to go to Mars instead of Venus, just to have another example, because I feel like when you're learning how to use Orbiter, when you watch like a quote-unquote tutorial, those are kind of useless in my opinion, because, you know, if your flight doesn't go exactly the way things went in their tutorial, then you're lost. So tutorials suck, they're useless. I like to just provide multiple examples, and then by providing multiple examples, you can refer to those multiple examples to hopefully achieve the task that you're trying to achieve. Now, this video is a direct continuation of part one, so if you haven't seen part one for some reason, stop this video, go back and watch part one, then come back here. So let's go ahead and switch camera views. And when we left off, we had just finished setting up our eject date, our new eject date, for when the Moon would reach the antipode position. And once we changed the eject date, we then had to change our outward velocity and our prograde velocity. And when we did that, it had a big impact on the trajectory that we're going to have when we get back to Earth. And that means that this red line that we laid down is no longer in the right place. You can see clearly that the halfway point between here and here is not there. It's actually farther up now. So we need to adjust where that line is at exactly. And the way we do that is simply here in stage 2 view setup. Let me unlock this, get it out of the way. In stage 2 view setup, we change scale to view from craft to target. Now we have access to this yellow line again, and we can adjust this red line so that it lays over top of the yellow line. So we're going to drag that down here, and we're going to drag this side up. Bring this down a little bit more. That might have been too much. Bring that up a little bit. And again, the idea, the preferable thing is to basically hide that yellow line, but it doesn't matter if it's off by 1 pixel or 2 pixels, but just get it as well as you can. So once we have the line adjusted, we can now switch the scale to view back over to craft or all. And now we have a new halfway point between here and here. So now for the level 2 refinement, we want to warp time forward until the Moon is about 45 degrees away from that line. Now 45 degrees may not be as easy to eyeball as 90 degrees, but in this little sheet that I've been working on, you know, I included a graphic here, and the reason it's not black like Transx is because I reversed the image so that if I wanted to print this out, it wouldn't use a ton of ink. But let's just read what we have here. For the level 2 refinement, you need to move time forward until the Moon is about 45 degrees from the antipode position. Note, the best way to do this is to use the scenario editor and move the date forward by exactly 3 days. From there, adjust hours only to get the Moon's position close to 45 degrees. There's actually a reason I say to do it this way. It turns out that as the Moon orbits the Earth, in order to move 45 degrees, it will always be the case that it's going to move at least 3 days. So if you just use the time warp, which you can if you want, you can just press T and warp time forward. But if we use the scenario editor and we go forward by 3 days exactly, then we kind of have more of a mental image of how many days we're going forward. So let's go forward 1, 2, 3. Now we have to decide if that's enough. And to me, I can tell it's not. That's more than 45 degrees. But by moving, we want to go forward at least 3 days. And now we can just adjust hours only. We don't need to worry about minutes and seconds, but we'll adjust hours only until we think we're about 45 degrees away. So I'm going to say, let me just kind of keep going here a little bit. I think we're getting pretty close. I've also included a graphic in this graphic. This is what 45 degrees looks like, and I actually measured it So this is exactly 45 degrees. So if you don't know, you can refer to this document and get an idea of what 45 degrees looks like. But I go on to say here, the amount of time that will pass between 90 degrees and 45 degrees is always at least 3 days, but it can be as much as 3 days and 19 hours. So start by moving time forward by 3 days, and then fine tune the remaining amount with just hours. And again, minutes and seconds don't matter. So that's what we're doing here. We're trying to find 45 degrees. And since I have that angle measurement tool, I'm going to go ahead and use it just so that we can see how good our angles are. And I think that's about 45 degrees right there. So bring up the tool here, and we're going to lay it right there on Earth. Good enough. And we draw the first line out to where the moon is at. Perfect. And then we cover the red line here. Perfect. And it's actually 56 degrees. So you can see my visual isn't very good. So let's go forward a little bit more. And we don't have to guess now. We can actually just move this to 45 degrees, which is right here. So we need the moon to be there. So I'm just going to go forward a few more hours. 1, 2, 3, 4. Just keep clicking the hours. And now the moon is 45 degrees away from the antipode position. So if you're better at visualizing than I am, then you don't need the angle measurement tool. But I can get the 90 degrees pretty well, but the 45, I guess I'm not as good at. All right, so what does that tell us? That tells us now, if we come back to this paper and we go back up to the top here, for their level 2 refinement, when we're 45 degrees away from antipode, that means that the moon is 3.4 days away from that point. And then the eject point would be 8.4 days out. Again, it's an additional 5 days to go from the moon to the Earth. So, and if it's easier for you, you can actually, instead of 3.4, you can say 3.5, but 3.4 is a more accurate number. So now we're going to say that from the date right now, which is 58219.47, we want to add 8.4 days to that number. So let's clear. Let's go 58219.47 plus 8.4 days. So our new eject date is 58227.87, so about 1 day farther out into the future than what we have here. And you can see that by doing the refinement this way, by doing it at 90 degrees and then doing it again at 45 degrees, we have a much more accurate eject date at this point. We're only off by 1 day, whereas the first time we do the refinement, it's several days off. So by adjusting the eject date by 1 day, the effect that it's going to have on this trajectory is going to be very minimal. But let's go ahead and set our eject date now, 58227.87 or 0.8. And we're going to go forward by 1 day, so let's go to medium setting. And about right. About like that. Let's actually back up just a tad. It doesn't have to be perfect, but it's pretty good right there. And you can see that the impact that it had on our orbital trajectory is very minimal, but we did have a big change in our closest approach because we're leaving a day later, so we need to adjust our variables here as needed. Let's see if we can add in, and we can add in some outward. That's good because now we're basically minimizing the cost. And it looks like we're going to get all the way back down just by adding in, or taking away, however you want to word it, some of that. Now it's starting to go back up, so let's go to the prograde, and let's see if we can take out some of the prograde, and that's sort of helping. Actually, let's find the low point. Let's overshoot this way. Let's go to okay, so just bear with me for a moment while I figure out exactly what I'm going to have to do here. All right, let's try it this way. Okay, 240, that's coming down. So I think I took out too much outward. So we're going to have to go back into the, yeah, we're going to have to take out some more outward, that's fine. Okay, back to prograde. Back to outward. And we're just going to go back and forth here until we get our closest approach all the way back down. So just bear with me while I do that. I'll do it as quickly as I can. Okay, we're almost there. A little bit more to get all the way down. And we're pretty much there. But let's now that we're getting close to the end of the refinement, let's get it pretty low. Get down to super setting. And we'll go with that. I think, yeah, now we're hitting the planet, so that's certainly good enough. Okay, now, again, as we make adjustments to the date and to the prograde and to the outward, it's going to have some impact on that trajectory. But at this point, it doesn't matter. The distance of, since Mars is farther out into the solar system, it's moving around the sun slower than Earth. It's moving around the sun much slower than Venus and much, much slower than Mercury. So these minor changes aren't going to matter, but we can see how much it changed. If we change the scale to view over to target, you can see now that the antipode position is now it's actually just a little bit further back, but it's so insignificant at this point that it really doesn't matter. But I mean, if you're really crazily meticulous about it, you could adjust the line again and then do another level of refinement, but I can assure you it's absolutely pointless to do that. Okay, so now that part is done. So let's switch back over to view escape plan here. Now what we need to do, since we're not going to do another level of refinement, if you're going to go to Mercury, you would want to do a level 3 refinement, which would be, show you here in the table here, a level 3 refinement would be when the moon was 22.5 degrees away from that antipode position. In other words, we would cut this distance in half again, so when the moon was like right here, we would go through the whole process again. But it isn't necessary when you're going to the outer, when you're going out beyond Earth, because the planets just don't move quickly enough for things to change. So we're done with that. So let's go ahead and get rid of our actually, let's not get rid of our tool yet. Let's leave that up for now. And we want to warp time forward now until the moon is right underneath of that position. So let's go ahead and do that. Could even use the date editor, speed that up a little bit more. And we're just watching the warp factor here. We don't want to go too far. And when the blue line is completely underneath of that red line, then we know the moon's in position. And we'll go with that. Okay, now we can even get rid of that red line. We don't need it for anything anymore. But we can see here, let's actually take a moment, go down to 0.1, and we can see just how there's still going to be some difference in our eject date between what we figured out when we were 45 degrees away and what we are now. So if we're saying that we're going to leave the moon right now, let's see, plus 5 days, so that would be 58228.0. So you can see our eject date's technically a little bit off, but again, it's not important. But you can see that from the time we went from here to here, the timing didn't work out exactly right. So now we're saying that we're almost 5 days, but it's not quite 5 days away from the eject date. So technically, we would need to bump the date forward by just a little bit more, but we're not going to do that. Okay, so now the next step is to set up Transx 2, and we can get rid of the red line. We don't need it anymore, so let's close that out. See how far along in this video are we? Okay, so let's bring up Transx 2. And while we're in view setup, let's go to let's go to nothing. Let's just go planets, moons, and we'll go escape. Then we'll go forward, and we want to view over to the eject plan, and we want to just put in the normal amount of negative prograde to get back to Earth. And once you get down to about that point, you can't really see very well, so press VW to get over to setup, and then we want to go scale to view target so we can see where we're going, then view back over to the eject plan, and change down to like a fine setting at that point. and then continue adding in negative prograde until you see that yellow perforated line come in like it is now. And again, something I'll point out, like I did in the last video, it should always be around this number. It's going to be, something more than 750, but something well under 1,000. If you ever see this, let's say you're doing your adjustment and you say, aha, okay, now there's the line, it's perfect, I'm good to go. But you look at your prograde and you see that you've got that much negative prograde, then what's happened is that you've actually put in so much negative prograde that you're overshooting, and you're going to be on a reverse orientation around the Earth, and that simply will not work. So if you have that be the case, then just add in prograde like this, and you'll see it'll switch around and it'll go back out the other side. And there we are. And that's what we want. So if you ever have more than like 1,000 prograde, then you know you've done it wrong. So let's view back over to setup, change the scale to view back to crafter all. Now we can come back on this side, and we can set up our plan for getting back to the Earth per the usual method. While we're in view setup, we want to change the graph projection to plan, because we just set it up here. That's our eject plan, so we want to use plan. And it also, I'd like to have in view setup the scale to view set to target here, because it just kind of zooms in a little bit more on the moon. And then we set our PE distance the way we normally do. Press enter, and we want 1758 E3. And then we're going to change our eject orientation. And hopefully this, getting back to the Earth is something that, getting back to the Earth using transx is something I hope you're very familiar with, so I don't have to go through as much detail as I would otherwise. We have two options. We have this option, which would go the long way. I'm going to go the short way. So if we bring the eject orientation around this way and line it up here, now we have the eject orientation that we need. Now there's one last thing that we need to do before we actually leave the moon. Going to come forward on this side and press VW, press VAR rather, to get around to the eject date. And we want to leave the moon when we are 0.15 past the current time. So the current time is 58223.02 plus 0.15. So that's going to be, we're going to leave the moon when the time is 0.17. And the reason we do that is because it just helps with our timing when we get back to Earth. We need to arrive at Earth so that we are in a specific position around the Earth to do the ejection. And it works out that if you leave the moon at the eject date that you calculated, your timing is going to be a little bit off. And Dimitri found that by adding just 0.15, and it's not just a number that he pulled out of thin air. He did some calculations and some various things to figure this out. But if you add 0.15 to your current time, then that's going to be the right time to go. So let's go ahead and warp time forward until we get to that point, which is again 0.17. Can go to 1,000. Just watching that number right there. Looks like we can even go 10,000. And we're getting close. Let's back off. And there we are, 0.17. Now what we want to make sure that we do here, notice that the moon has moved its position, from there to there. So we need to change the eject date, or we need to reset the eject date like that. And now let's actually come back, and we'll need to check our eject orientation and everything. I kind of did these steps a little bit out of order, but it's fine. The important thing is just after you warp time forward, make sure you reset the eject date, or else things aren't going to work out. So that's it. We are ready to go. And it helps too, you don't have to do this, but you'll get into orbit much faster if you dump a lot of fuel, because we only need 3,000 delta V total or something like that. Let's see. We need about 500, 400, 500, something like that when we get back to Earth. Then we need about 2,000. We only need about 2,500 total. So I'm going to go to propellant, and I'm just going to send this all the way down to like 0.10 or something. That's fine right there. Apply, done. And let me just double check in burn time calculator to make sure I'm not underdoing it. No, that's fine. 3700 is fine. Okay. All right, so now we're going to come back to stage 1 over here and make sure we have view escape plan up. At this point, it's probably not a bad idea to have you transx 2 on one side, transx 1 on the other side, and control S. I always like to do quick saves throughout the flight. Normally I would do it more often than this, but at the very least, now that you're getting ready to take off, it's a good idea to save so that if something goes wrong with your takeoff, then you can come back to this point. Take a sip here and then we'll get going. Okay, so transx tells us we need a heading of 246.4 degrees. And remember, it's important to keep that heading in mind because as soon as you lift off, it's not going to be there anymore. It's going to be replaced by relative inclination. So I'm going to bring orbit up on this side, projection over to ship, and distance over to PEA, APA. I think I tend to prefer to have orbit MFD up. You can also have surface MFD up, but I think orbit MFD is a little bit better for me. So now we're ready to hover up and get over to that heading. So 246 is going to be about right there. So let's get going. Raise the landing gear. Rotate. And it was 246.4, so we don't want to go all the way to 246. It's about halfway in between, about right there. Full power on the main. Get rid of the hover and pitch up just enough to prevent the velocity vector from dropping below the horizon, which is why I don't need surface MFD. I prefer to just have orbit MFD up, and I know if I'm going up or down based on the velocity vector. Okay, we've overshot. Oops, that's a bit much. We overshot our relative inclination, so I'm just putting in a bit of correction to keep things in check. Looks like we got a pretty good heading right here. You can see the relative inclination coming down slowly. And we're going to be at orbital velocity very fast because, again, we almost have empty fuel tanks. So we have just a whole lot of acceleration here. If we need to, we can do a bit of an adjustment. It's not really necessary. Okay, now I just need to watch the apoapsis. 20 kilometers is our target. A little bit more acceleration. And there's 20. It doesn't have to be perfect. You can see I overshot by 0.32 by 320 meters. So now we're going to switch over to the orbit HUD, and we're going to ask ourselves a question. For one question we can ask is, how do we do on our relative inclination? So we can adjust our white line to bring it right over top of where we are right now, and we can see that our relative inclination is very good and it's trending down, so we don't need to worry about it. When are we going to reach apoapsis? We're not going to reach apoapsis until this point, which is like actually right about the time we're going to eject. So we probably won't have to circularize. We're gonna eject almost at the same time that we would normally do our circularization. But as I've stated in other videos, if you reach your apoapsis first, like let's say you reach it here or something like that, then you want to make sure you circularize, because otherwise you would reach apoapsis and then come back down and crash before you ever got to the eject point. In this case, we're going to reach the eject point before we impact the surface, so we don't need to worry about it. Okay, now the next part of the setup requires setting up a maneuver, and I'm going to save that for the next part of the video. So if you like this part of the video, hit the like button. If you didn't like it, hit the don't like button. And subscribe to the channel if you're not already subscribed. You know what I just noticed? I just noticed my camera isn't mirrored. I remember unmirroring it for some specific reason, and then I forgot to redo it. So in between videos, I'll switch it back the other way. The reason I like to have it mirrored is because when I'm looking at this MFD, I'm looking to my left, and in the video playback, it looks like I'm looking to the other side. So I'm going to remember to do that. Anyway, check for links in the description down below. Subscribe to the channel if you're not already subscribed, and I will see you in the next video. That the halfway point between here and here is not there. It's actually farther up now. So we need to adjust. We need to adjust where that line is at exactly. And the way we do that is simply here in stage 2 view setup. Let me unlock this. Get it out of the way. In stage 2 view setup, we change scale to view from craft to target. Now we have access to this yellow line again, and we can adjust this red line so that it lays over top of the yellow line. So we're going to drag that down here. Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the Earth to, actually I guess it's a Moon to Earth to Mars video series that I'm doing. And this is not a mission. We're not going to do a full mission. This is just to explain how to start off on the Moon, drop down to Earth to get that gravity sling, and then go off to another planet. I've already done another video on this topic, actually two, but hopefully you've at least seen the last one where we started off on the Moon, dropped down to Earth, and went off to Venus. I'm going to do another video just like that one. And we're going to drag this side up. Bring this down a little bit more. That might have been too much. Bring that up a little bit. And again, the idea, the preferable thing is to basically hide that yellow line, but it doesn't matter if it's off by 1 pixel or 2 pixels, but just get it as well as you can. So once we have the line adjusted, we can now switch the scale to view back over to craft or all. And now we have a new halfway point between here and here. So now for the level 2 refund, where I'm explaining how to go to Mars instead of Venus, just to have another example, because I feel like when you're learning how to use Orbiter, when you watch like a quote-unquote tutorial, those are kind of useless in my opinion, because, you know, if your flight doesn't go exactly the way things went in their tutorial, then you're lost. So tutorials suck, they're useless. I like to just provide multiple examples, and then by providing multiple examples, you can refer to those multiple examples to hopefully achieve the task that you're trying to achieve. Now, this video is a direct continuation of part 1, so if you haven't seen part 1 for some reason, stop this video, go back and watch part 1, then come back here. So let's go ahead and switch camera views. And when we left off, we had just finished setting up our eject date, our new eject date, for when the Moon would reach the antipode position. And once we changed the eject date, we then had to change our outward velocity and our prograde velocity. And when we did that, it had a big impact on the trajectory that we're going to have when we get back to Earth. And that means that this red line that we laid down is no longer in the right place. You can see clearly